In this example, I'll look at the watch, locals, call stack, and thread windows inside Visual Studio. I'm inside a project called Using Watch Windows. This is a WPF application, and I have a little sample UI down here in main-window.xaml. Let's take a look at it. There are 6 buttons in here, and each of these buttons allows me to show you one of the windows inside Visual Studio. Now, before I show you the actual windows, I need to build my application. And then I'm going to attach the debugger by clicking Debug, Start Debugging. Then I'm going to click on this Watch Windows button. Notice that I have this code in here that causes the debugger to stop automatically if a debugger is attached. I talked about that in the previous movie. I'm going to press F10 to step through a few lines of code. Now, the idea behind the watch window is it's a permanent repository for data that you want to look at. So if I want to keep this S1 around, instead of having to hover over this to see what's stored in there, I can just take it and drag it down and drop it into the watch area. And then when I see the data down here, I notice that there's an error. I can fix this while I'm at a breakpoint by double-clicking on the value in the watch window, typing in the new value, hi. And it shows it red now. That signifies I've just changed that value. Now, if I hover over the S1 variable up here, you see that it now contains the new data. So I can edit the data and watch the data. Of course, I can drag more sophisticated objects down here, like this book object, and then I can click on this plus symbol to expand the details and read more about this class. I don't have to use variables that I've declared. I can work with the local class. I'm inside this main-window.xaml file right now as I'm running, so I could come down here and type something in, like the word this, which refers to the current instance. And then I can read information now about this window I'm inside. Also, I can see information about some of the buttons in here. And I can also use completely arbitrary calls out to .NET Framework. For instance, I could say system.io.directory.exists, type in the path to a directory, so, and then it will evaluate that expression and tell me that no, that directory does not exist. Next, I'd like to show you the locals and autos windows. So I'm going to press F5 to finish running the code in here and return back to my UI. Click on the locals and autos button. Now I'm going to take a look at these 2 windows here and here. So the autos windows watches your cursor, and as you step through your code, I'm pressing F10, it's keeping an eye on the line of code where the yellow marker is and several of the lines of code around that marker. So right now I can see 3 variables. If I press the F10 key one more time, you'll see that those variables change. Now compare that to the locals window. The locals window shows me all variables that are in scope inside this method. So that would be the sender, which is a parameter, the routed event args, which is a parameter, plus also these other variables here. Now, as I step through my code, I'm going to get to this line of code right here, 68, and that's going to move me into another function. So as I press F11 now, I have now entered the second function, and you notice that the locals window changes and shows me only the variables that are in scope inside that function. Pressing F11 a few more times, I will leave this function and return back to the previous calling function, and then again the locals window repopulates with the data from that area. I'll press F5 to continue. Next, I want to show you the call stack. In this example, I have a function called callStackButton_click, and it's going to call a function called createLoan. So if I go over and click on this call stack button, now if you don't see these windows, you may need to go up to Debug, Windows, and enable the different windows. As you can see, there's a lot of other windows I'm not going to cover. For instance, there's the registers window and the memory window. So here I am, I'm ready to make this call. If I look at the call stack, I see that I'm inside this function. Now I'm going to press F11, and I've entered the second function, and the call stack now reflects that and says I am in this createLoan, and it was called from this button click procedure. One of the things I can do in the call stack window is double click on the previous function, and it will take me over and show me where the code was where I entered this function. Then I can double click on this one with the yellow marker, which takes me back to the current line of code that's ready to execute. I'll press F11 a few times. Now I've entered another class, and you can see the call stack is now 3D. And then when I leave this, it goes back to being too deep. Press F5 one more time. Let me click on this button. The immediate window lives over here. And what the immediate window allows me to do is run one single line of code and evaluate it. So right now, I would like to call this function financial create loan. So I'll come over here and I'll type in FIM, there's financial, dot create loan. I pass the person's name in, and then I pass in the value of the loan, $5, and I'm going to press enter. And that function just ran, and notice nothing happened up here, right? I'm running this function independently of what's happening in this window. And then I get back the results from that function. I can also print any details I want by typing in the question mark, which is shorthand for print. And then I can type in something like this dot width. Here I'm referring to the window that I'm inside. And I can find out that I'm 525 pixels wide. Press F5 one more time. Next, I want to look at the thread windows. So I'm going to click on this button right here. I'm inside this click procedure. By going in and choosing debug, windows, threads, I can examine how many threads I'm running. Now, you may not see the same number of threads that I have here. I've got 2 threads. It depends on whether you have this thing called the VS host running or not, which is a special debugger helper. If VS host is running, then you'll end up with 4 or 5 more threads than what I currently have. So I've got the main thread, and I've got 1 worker thread. Now, I have another example. Let me press F5, where I am going to spawn a worker thread to go do some extra work. Let's make this a little bit smaller. What I'm going to do here is I'm going to queue up a thread from the thread pool and tell it to go run the code in this open the files method. So currently I'm on the UI thread because I'm running inside this WPF application. When I get down to this line of code, I'll be running on a thread pool thread. So I can see the difference in this window. I'm going to press F5. Now I've hit this breakpoint that's inside the open the files function. And as I can see in this thread window, I'm now running on this thread down here, 1352. As you saw earlier, there are other debug windows available. For example, there is the register window, which shows the data that is stored in the CPU registers. These additional debugging windows are adapted for special debugging tasks and worth investigating.